Hello everyone, welcome to the video. So what is this video about? We are going over the uname command in Linux and how I made it better, right? So uname is a standard utility on Linux. It's used in a lot of scripts to determine what to compile for and whatnot. Um, so yeah, you can get like kernel name, node name, release, version, machine, processor, blah, 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 blah. All sorts of things. So let's go over what I did with it. My implementation is smaller, arguably faster, and definitely better. It is better because it is statically linked, and I will show you why that is better. But first, let's do something. Let's have a look at what is the original uname command and what's the size of the utility. So if I run which uname, that gives me where it is. So if we do ls, lah, or actually, since I have an alias, okay, well, I don't have the alias then. So let's just create that. So size, and that is going to be lah. And then if I were to run which uname, that shows me that it is 31 kilobytes, right? The original uname command. I am on a old Ubuntu machine, by the way. However, the uname command, it pretty much stayed the same ever since 1991, if I'm not too wrong. Now, I have the BSD implementation of uname. Here it is. I have grabbed it all the way from BSD, the official repositories. Let's compile this with GCC. We are not going to statically link this, just dynamically link it. And we're going to see what the size is, right? So let's do GCC uname and then output it to be uname. And then let's have a look at the file type. So it says it's dynamically linked, right? And it is an ELF64, not stripped, right? So it is not syntactically optimized, let's say, whatever the compiler outputted. It's not stripped. So let's look at the size, right? It's 15 kilobytes. Definitely better than whatever GNU was supplying. Pretty good. Now let's try to compile this with musl. So what is musl? Musl is this implementation of libc, the standard, that is far smaller, more POSIX compliant, and it is also very stripped down, so it doesn't have all sorts of helper functions that the GNU library has. So what that means is that it's more platform agnostic, so you can write code for Linux and it most of it will run on any other Unix based operating systems, right? So it is pretty good, and it's really easy to statically link things with it, and it drastically reduces the size of the binary. And the thing about statically linking things is that you no longer have to worry about what system somebody is on, right? They might not have the correct libc version, they might have some library conflicts, whatever, right? Whatever. We don't need to bother about that. So let's try to compile this. And I also have an alias for the musl compiler since I don't have it on my path. I'm not exactly sure why, but yeah. So that is where my musl compiler is. So I'm going to run musl gcc and then uname.c and then output it to be uname. Huh? What? Very interesting. See, that's another thing, right? It is not musl compliant apparently. The BSD program, it will not compile with a musl system, and that is terrible because that clearly means that it depends on something that not all computers are going to have, right? We can probably have a look at what that is. So let's see if I do have it. So /user/include/sys/ I'm not exactly sure where that header file is located, but this goes to show that the official code for the BSD distributions is not musl compliant, which means it's not properly POSIX compliant either. So let's try to compile this, but statically link it this time, right? So uname.c and then output it to be uname. And let's even optimize this, right? Sure, why not? So let's optimize this guy, and actually no reason to do that. And that's in fact just going to increase the binary size, trying to unroll some stuff and whatnot. And let's statically link this, right? So let's file this again. So uname. It is statically linked this time. Pretty cool. And if we size that, then we see that it is huge. Right? It is 906 kilobytes. My God. That is unacceptable. But at least it's not dynamically linked, right? So if I were to ship this to anybody, they would be able to run it. However, my implementation, now this thing works, okay? So let me show you the makefile for this so that I don't confuse any viewers. Right, so I'm using the same musl compiler, and I am, these are just warning flags. I'm optimizing it to the second level. I can take that off for now. But even if I do keep it, that's not going to be a huge disadvantage, right? My God, I cannot type. And it is statically linked, and I am actually keeping the intermediary file, so I am keeping the object file, which is created with this little makefile rule. I think that's what they're called, recipe actually, regardless. So let's make this, and what we have is a uname command, right? And if I were to file the uname command, it is statically linked, okay? And if I were to show you the size of the uname command, it is 34 kilobytes. However, it is statically linked. What does that mean? That means that if I were to ship this to anybody, they would be able to run it. It is quite small. It's only a bit bigger than the dynamically linked one that the BSD code supplies. However, if I were to not statically link this, right? So if I were to say musl gcc and then uname.c and then output uname. Oh yeah, of course, that makes sense. Oh God. Yeah. Right, let's have a look at what this gives us. It is smaller. It is a lot smaller. However, this is not worth it. Okay, to me, this is not worth it. This slight reduction in size, although it is smaller, it also means that if I were to supply this to anybody, package it and whatever, I would have to probably supply some library files, probably create an entire directory and then set up new make files for that. Absolutely not worth it. So let's just clean this and make this. And for now, my implementation is complete for the most part. So I can ask for the version. It is version 1 because I don't imagine I will be working on this for too much longer. The help is not yet implemented, so that's a good thing. We get to write some code right here. But everything else works, right? So let's go over there and let's man uname. Right, so let's try to print out the kernel name. So /uname and then s. And that shows me that I'm on Linux kernel. I can have a look at what the node name is, which is essentially the host name, which should be the same as this. So let's do that. Actually, no, that should not be the same as that. The host name is the name of the host, not the user. So let's do that. And yes, it is correct. That is the host name. So clearly, it all seems to work. However, I don't have support for uname A, right? So I do not give out all the information at the same time, the way that the old uname does. So we are going to be fixing that. So what do we do? Let's bring over the second window here, right? And Actually, let's just start working on the uname musl.c. So, right, let's go over some of the code here so I can explain what I've done. Right, so these are all the libraries that I've used. I'm not sure if I need all of them. Maybe I don't. I will optimize this later, maybe, but not really a big deal. The usage command is not yet implemented. This is exactly what is supposed to give out. Oh God. Yeah. So this is exactly what's supposed to give out let's see, this text, right? This function is supposed to give out this text. I have not implemented it, but it is extremely easy to implement, so it is all right. So what are we doing? We are grabbing the number of arguments being passed into the binary and creating a vector of that. And if the person has not given out any arguments, we are going to print the usage, like not usage, but like call the usage function and return with a 1. So 1 means that something fucked up. Right. Next. So here's where the argument parsing really begins. So we are using something called getOptLong. Now this actually was a pretty big issue for me because if I show you the getOptLong, actually let's just you will see that this is the function that I want to use. I could have just used the getOpt, and getOpt is fairly POSIX compliant. Okay, this is in standard C. However, about getOptLong, right? This entire function here, this was sort of a problem because if I were to go to these don't exactly conform to the POSIX standards. These are GNU extensions, right? And that is a slight problem, in fact. So again, that reinforces my point that GNU just keeps adding whatever they want and they don't care about the standards. However, the good thing is, after a little bit of searching around, I found that the good guys over at Musl have already implemented this. So this is the implementation file. And if you look at the interface, yes, it is available. Sweet. How does this work then? The problem is that the manual is fairly confusing, so I'm going to be explaining it myself. So what's the idea? We essentially pass in the number of arguments, the vector of arguments, and a string of possible arguments, right? So S, N, R. Actually, we should probably get another window and open up uname so that we have a list of all of the possible arguments. Nice. So there's S and N and R, V, M, P, I, O, all of them. Now, and this part is generally quite easy. Okay, so what would happen if I were to just use getOpt and not the long version of it? What would happen is that I would not have to put in this part, right? So essentially what happens is that it returns which flag was turned on. So in case I said S, it's going to execute this part, right? So I'm using a switch case. So this returns the ch, the getOpt. And if I passed in S, it would set ch to be S. And then I'm getting inside of a switch case and I'm running these cases, right? And I'll explain what those cases are. No worries. So that would work. However, I also need support for long options, right? For example, help and version. For that, I will have to use the getOptLong variant. So how does that work? For that, you have to use a structure, right? You have to use an entire structure for that. And this is the structure, right? Actually, let's have a look at the interface first. So it takes in a constant structure, option, and long opts. What that means is that it takes essentially a pointer to an array, not a pointer to an array, just an array of structures. And the type of the structures is just option which is defined in somewhere. Yeah, it's in get opt, and yeah, that's the idea. And then it takes in an index, right? So the long index, which we are setting to null for very good reason, and I'll explain why. And the structure is essentially this, right? So struct option is defined like so. It has a name, then we set has arg. So what does has arg mean? You know, sometimes when you're using some Linux utilities, right? Let's get there. Right. So when you're using some utility, you can pass in some flag here, and then you can input some, how do I say it? Some argument, right? You can put in some argument in there. And that is quite useful. However, we don't need that, okay? Uname doesn't really need to take in any arguments. So we are going to set that to 0. And then int flag. So what that means is that a lot of times in Linux utilities, the long flags actually correspond to some short flags, maybe. What that means is that if you were to say dash dash kernel name, that would essentially map over to /s, a dash s, right? So that's the idea. Again, not something that we need here, so we are also not using that. And finally, val. So val is that we can set the exact value that we want to return if this long option was passed in. So that is what we are doing in here. So what's the idea here? We initiate a structure, an array of structures of type option, and we have 2 elements there. Later on, I do intend to add in more long options for more complicated processing. However, not necessary right now. So the first one of them, at the 0th index, we are using a very cool way to initialize things. I did not know of this, but my learned friend from GDG, name is Partho, he taught me this. So you can apparently just, if you just write down things in sequence, the entire C compiler pretty much puts them in place, right? So help, and then 0, and then null, of course, according to this. So the name is going to be help, and then the has arg is set to 0, and then flag is going to be set to null, and the value that we want to return if help option was passed in is 100, right? However, turns out, since this is quite, how do I say it? It's quite ambiguous, okay? Because maybe the compiler doesn't exactly know how to map them. So what we do is we also typecast this to be struct option. And we do something very similar for the second one, which is just version, for which we return 101, right? Okay. Now let's have a look at how we are. So we have successfully managed to parse the arguments. However, what do we do with them? So we use a little byte. Okay, we are using a byte. It's called flags, and it's an 8-bit integer. So let's get a representation for that here. So that is it. So what are we doing? Initially, we set it to 0, right? So like all 8 bits are 0. Now, what we are doing is, if the user turned on the S flag, what we are doing is that we take whatever was in flags, which is in the beginning just 0, and we bitwise OR that with opt kernel name. So opt kernel name is just a flag that I've set, right? So that is just 1 shifted left by nothing, right? So it's just 1. So the equivalent of that is just going to be 0, 0, 0, 0, and then 0, 0, 0, 1, right? So that's the one. And if we keep going, this is 1 left shifted by 7 bits. So it's just essentially this and then this, right? Okay. So essentially we just keep on ORing them. So at the end of this, if somebody turned on, let's say, the S and maybe the P, only those bits would be set to 1. That's the entire idea here. I hope that makes sense. Right. Now that we know that, what we are going to do is, Also for the, since we are not working with these help and version options, we just directly return something from the switch cases. So in case this get opt long returned 100, which means somebody asked for help, we just call the usage function, and if they ask for the version, we just print out version 1, right? Next, now this is where my implementation of uname varies from the implementation in the BSD source code. So let's have a look at bsd/uname.c. This is a decent code. Okay, this is decent code. So what's happening here? They're setting flags, they're hard coding them. Quite weird, very like unreadable code right there. They're using function pointers. What this means is that they're creating a pointer type which holds the address of a function that takes in void and then it returns void, and they're calling it getT, right? And they're creating a lot of those function pointers for and they're called get build id, get ident, get platform, blah 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 blah. They're also creating some functions, some interfaces called native ident, native platform, and whatnot. So what they're doing is that they're argument parsing first, and then actually I shouldn't explain the entire thing. So the idea is that they check, right? So they call a getenv. Where did it go? So they call a getenv, and they try to check if the shell's environment variables, right, if the values for sysname, hostname, release are exported already. If they are, we are not going to call the uname syscall, right? That's how they want you to optimize it. This is off of the BSD one. However, I later realized that for the most part, nobody's going to have all of these values exported. Okay, who even has that? So I just thought we should just, and this is a lot of branch prediction. Okay, this is a lot of branch prediction. We do not want to put ourselves through that. Very hard code as well, right? Like a lot of macros. They're using operand pasting. So like var gets pasted in there. This is meta programming, insane stuff. Yeah, so essentially what they do is if they're saying that if you don't find these variables defined, then you are going to call these native function, and then how they create the native functions is here. They seem to be calling the uname syscall regardless at some point. So I thought we don't need to do this, right? Also, since I'm mentioning the uname one, so let's go to line 2 uname, and this is the uname syscall. So what happens is that we call this, it returns an int, which means that if it's 0, that means it worked. Okay, right? And we pass in some buffer, right? Like we initiate a struct called of type uts name, which is defined in this header file, and we just pass the address of that. And what the kernel does is that it goes in there and it stuffs that structure with the values for sysname, node name, release, version, blah blah blah, and then it just returns us the entire structure. Not returns us the entire structure, it just fills them up because we passed in the address, not the entire variable, in fact. Yeah, that's my Rust brain speaking, I think. But yeah, what's essentially happening is that we get the entire structure loaded up, and then we can just go around printing whatever we need to print. However, I thought this was quite wasteful, so I just did not do that. So my implementation just immediately runs the uname syscall and loads up the entire structure. And then finally, what happens is that once the entire structure is loaded up, we go into this entire loop. This loop is in fact very interesting. Let me explain why. So we create a variable I of type size t, which is set to 0, right? So let's write the binary representation of that. So 0, 0, 0, 0, and then 0, 0, 0, 0. Okay. And what we do is that we, okay, actually no, this is just, let's just write this as 0. This doesn't need to have a binary representation, my bad. So what we're doing is we are taking the size of flags. So the size of flags in this case is 8 bits, right, or an entire byte. So we take this size of, so size of returns in bytes. So this essentially evaluates to 1, that multiplied by 8. I have written it this way because this means that upon further extension, for example, if I were to add more short flags, I would need a bigger flags variable, maybe 16 bits or something. And then I wouldn't have to write anything here. Okay, I could just write this to be 16 and that would get the job done, right? And then I++. So each time just this I just goes from 0 to 1 and then blah, blah, all the way over to essentially 7 here. Now, what we do is we take 1 and then we left shift it by I. So at first it is just going to be what? 0, 0, 0, 0, and then so like, right? Yeah. So it starts from there and then it keeps getting shifted left. Okay. And then what we're doing is we are bitwise ANDing it with the flags and we are checking. So if bitwise ANDing it with the flags gives us, so let's consider something, right? This is going to be fun. So if the person passed in only the S flag, okay, then the flags variable would look like this, and the ANDing it with the first variation, which is just 1 left shifted by 0, would give us the exact same thing. And what we are doing is we are just checking it with these cases. This, in fact, if you remember, this is just kernel name, isn't it? See, it's just kernel name. So we are checking that if it is kernel name, printf u, which is the structure that we loaded up from here, and dot sysname, we just print the damn thing up. And we just keep going like that. So then we left shift it again, and if that says, and if that value after ANDing equals to opt kernel release, then we print that out. If not, we don't. Right? Very clever stuff here. Ooh, I might have some syntactical errors here. That is not good. Yeah. Yeah, that's essentially what's happening here. And oh yeah, there's actually a little exemption here. So here's a problem, right? If you take a look at this, you will notice that this doesn't really have a field for what OS you're using, and rightfully so, because your the kernel doesn't really know what operating system you're running on top of it. So yeah, there's no way to call a syscall and check what OS it is. One way to check what OS it is, sort of, is if we were to just cat out the contents of I think etc/os release. That would give us exactly what the distribution we're using, but sadly, as you can notice, it nowhere does it say Linux, right? And that is quite sad. So that's why what I've done is that I've hard-coded this. If the sysname, at least we can check the kernel. And for the most part, if the kernel is Linux, most often what's going to happen is that it is going to be GNU Linux, right? Although I did put a question mark in there because there are some non-GNU Linux distributions now, and I am in fact writing this utility for one of them. So yeah, and then I just don't support anything else, right? So if you're not running Linux kernel, I don't know what you're running. I don't know what operating system you're running. Okay, I know what kernel you're running. This the syscall will work on any Unix-like operating system. However, I can't tell what operating system you're using, and I don't need to. You know why? Because I'm not going to license the software under proper GNU and then call it POSIX compliant. I am not POSIX compliant. I do not care for compliancy. Okay, I'm writing this for a very specific distribution and for very specific users. If this gets the job done for them, I'm happy. I do not care. Right. And that's pretty much it. That's the entire idea here. So now let's implement the help, right? Also, why am I not implementing the a flag, right? Why does my uname not have a uname a? That's because I'm lazy, right? Because if I were to include a in here, then I can no longer make do with just a simple little, you know what I'm saying. Actually, it is all right. You know what? Let's just implement it. So opt all is just literally going to be okay. Let's think of the largest value. Actually, what we can do is let's do something fun here. Oh my god. Let's set uint. Oh my god. Uint 8 underscore p opt all to be not of 0, and that's it. So 0 would result in 8 zeros, right, in the entire byte. But oh yeah, it's all right. But if we are not that, it's just going to turn all of them into ones, right? So that's the opt all, if that makes sense. I hope this works as well. I can't tell if this works. I'm not a C programmer by trade. I write Rust code, okay? Now let's change these actually. For example, this will need to be 16 now. We can no longer make do with 8. However, I think all of these can work with just an 8-bit thing. It doesn't hurt to put it to 16 as well. I'm no longer going to be writing out entire byte representations, and the reason for that is that I'm lazy. Okay, 16 entire bits, you want me to write that out? Hell no. Okay. Right, all of this logic will still work. However, and now we have an entirely new option, don't we? And if we have an entirely new option, what we will have to do, actually, I'm just being dumb. I could have just added all as like a long option, but it's all right. It is all right. No worries. So let's write a case here. So case A, if this has returned A, what does that mean? We are going to take the flags and we are going to OR it with the opt all, right? And we're going to break. All right, so essentially just set everything to 1, 1, 1, 1, 1, 1, 1, 1. Well, that's going to be it pretty much. However, this is going to be set to 16. Let's see, is there anything else that needs updating in the code? I feel not. I feel like it doesn't. Yeah, let's try to compile this maybe. Let's make clean everything first. So make this and let's try to do uname A. Yeah, okay, we now have all support. Pretty cool. Okay, let's add support for usage finally. So what is the usage like? Actually, this one can be killed. This is the last thing that I'm going to do. I'm very hungry and I need to go get lunch. Right, so actually, I suggest you stop watching this part of the video, honestly. This is going to be extremely boring, but what has to be done, you know? It is how it is. Also, what the fuck? Come on, are you not going to let me select things? Okay, you are. I just needed to go there. What should we write? I feel like I can just type things out faster than I can copy, in fact. So, puts uname print system information, and then that, and then what else would this need? I don't want to give out a synopsis because that is not necessary. In fact, why am I copying this off of the man page? Why not just go like this? Yes, I think that's the idea here. Let's do puts usage is uname and then option, right? And then next line. Actually, just to make our lives a little bit easier, what I'm going to do is, let's try to uname help and then put that in uname help, right? And then gedit the uname help so that we can now copy paste a bit easier, right? So I feel like that should be all right. And then we can go like what's yeah, this is going to be an entire issue, you know, putting all of this in, because yeah, this is going to look nasty. We're going to have to put in a tab in there. Actually, no. There must be some easier way to do this. Let me think. Fuck off. Right, there must be some easier way to do this. What if I just copy over all of these lines? Right, and oh god, no. Yeah, what if I were to copy over all of these lines and then paste them and then what I could maybe do is that, okay, you are slightly weird, aren't you, buddy? Okay, so this is exactly what I want to put out, right? So what I should be able to do is that each one of these lines should be put inside of a puts, shouldn't it? I think yes. Right. So let's record a little macro actually. So the macro will be recorded. We go to 0 and then wherever the thing starts to begin, and then we write down puts this tab and then escape this and then go there, delimit this, do this, and then we go down. I feel like that is the macro, and we stand to find out if that is the macro. That is the macro. Oh no, is that the macro? That is the macro. Huh, gorgeous. So, and now we can just run it 9 more times. Pretty cool, yes? So 9 at 1. This needs to be run once again. All right. And then if we format this code, maybe I think we cooked. So let's make this again. And then let's do uname help. I have cooked. See, I'm like that. I am truly like that. That is it, guys. I hope you had fun watching this. Maybe I should make more videos in C or Rust or whatever you would like me to program in. And I will see you guys in the next video.